Now, recognizing algebraic patterns can also help you solve these problems quickly, and also help you in converting expression into one form into another form. Okay, so some of the key ones that is typically focused on in the SAT exams are perfect square trinomials, right? So you know this identity, which is a plus b whole square is equal to a square plus 2ab plus b square. So if you remember this identity, you can use this to convert this form into this form. Okay, difference of squares, a lot of useful uses, like a square minus b square is written as a minus b times a plus b. This appears frequently in a lot of DSAT equivalent expression problems. Sum and difference of cubes, right? So if you take this one, right, difference cube, a cube minus b cube is going to be equal to a minus b times a square plus ab minus b square. And similar formula also exists for a cube plus b cube. And I will, allude to that. We have in our slide, we have, this formula too, which is also basically factoring formulas, right? So that could be written as, two different factors, right? So I will give you this formula in a little bit, but again, the idea here is you should definitely focus on remembering these four key formulas. One here, which is the square, a plus b whole square formula, a square minus b square, which is a minus b times a plus b, and then the third, which is cube factoring, difference factoring, and the fourth, cube plus factoring. Okay, so this equation is a cube minus b cube is equal to a minus b times a square plus ab plus b square. And again, a cube plus b cube could be written as a plus b with a factor that I will show you later in one of the example problems. Okay, so these are the four algebraic patterns that you should be familiar with, because they are widely used in equivalent expression problems in DSAT and also at various high school math problems in general, right? And so these are very, very useful formulas, and hopefully you probably remember them by heart. If not, I will definitely encourage you to focus on creating flashcard and memorizing them, because they can help you solve some of the problems, not only in equivalent expression, but also in other mathematical problems in DSAT, also in high school problems too. Very useful formulas. Okay, so here are some of the examples of this, right? So if you look into this, right, perfect square trinomial, right? So this is the equation that has been used here. So if you have this factor, right, you can recognize that I can write this as x squared plus 2 times x times 6 plus 6 squared. Okay, so this is here. So from here, if I now take my a in this case is x, and my b in this case is 6. So I can write this x plus 6 squared, because we have this form, right? So recognizing this, and from there recognizing that you can write this in this form, which is x squared plus 2 times x times 6 plus 6 squared, you can write this as x plus 6 squared. This one is easy. A minus b times a plus b. A is x, b is 5. A minus b, a plus b is a square, which is x square, minus 5 square, which is 25, right? So that's how you are using this identity, right? And here is an important of factoring, where none of this is done here, but we will focus on this one. And I will show you how to factorize this one going forward, in a little bit, right? So let's hold this one, but I will show you how to do this. There is a trick for doing this, and I want to specifically focus on a trick and have that as an example problem. So we will come to this one a little bit, okay? But hopefully you saw a plus b square, a square minus b square uses, and how you can recognize them, and you can see, right, they lead to equivalent expressions that might look different. So this is definitely looking different than this, but they are essentially the same thing, right? And the same is the case for this one. Okay, so now let's move on, and let's talk about equivalent across different forms. So you might have, as I said, that you might have different forms. So here is an example where you have an expanded form, which is written as x squared minus 7x plus 12. The same thing is written as the factored form, which is x minus 3 times x minus 4. And if you expand this, you will get exactly this. Now, these two equations are also written in what is known as vertex-like and structured form, which is here, which is x minus 7 by 2 whole square minus 1 by 4. And this, if you expand it and you subtract all of this, will be exactly the same thing. Okay, so equivalent expression can exist in different forms. So the same expression might appear in expanded form, factored form, vertex-like or structured form, right? And the DSAT questions often ask students to move between forms because each form reveals something different. Factored shows zero, expanded form shows coefficient, and structured form show hidden patterns that might be there. And that is why the questions are asked, because different forms show you different property of that equation. And if you can do conversion, you can learn various different aspects about that equation. And that's why equivalent expressions are an important topic in general in math, and it is being emphasized in digital SAT for sure. Okay, let's move on to a medium hardness problem. This is A and this is B. So this term is A minus B whole square, which is different than A square minus B square. So A is 2x and B is 3. A minus B whole square is different than A square minus B square. What is this? In fact, this is A square minus 2AB plus B square, which is completely different than what we have here. So, as I said, A minus B square is equal to A square minus 2AB plus B square. And assign A equal to 2x, B equal to 3, then this becomes 2x square minus 2 times 2x times 3 plus 3 square. And if you simplify that, that is going to be 4x square minus 12x plus 9. And you can also write this and do the individual product and get this answer. But remembering the identity A minus B whole square equal to A square minus 2AB plus B square will help you solve this problem more quickly rather than complete expansion of it.